vector database and RAG. Have you ever wondered how to enhance RAG using the power of a vector database? Well, we are about to embark on the journey to create a vector database using qdrant. But before we begin, let us talk a bit about the process of vectorization and text embedding and why we perform these operations. Let me explain this concept by going back to the basics, where we talked about the predictive nature of these language models. When you interact with ChatGPT and write a word, the model doesn't just consider the word in itself. Rather, it examines a special mathematical representation of that word, known as a vector. This process begins with text embedding, where every word encountered by the model is turned into a vector, which is simply a series of numbers arranged in a multi-dimensional space. Imagine this space as a vast map of language, where each word is assigned a location based on its meaning and in the context in which it's frequently used. Words with similar meanings, or those that often appear in similar contexts, are located close to each other on this map. For example, the word apple is not just seen as 5 letters, but as a point in this space located near fruit, pie, and juice. The proximity of the word apple to these words is due to the model's learning from a corpus of texts where apple often appears alongside them. So when you type apple, ChatGPT looks at the vector of apple, considering which words have vectors close to it in this linguistic space. It asks, who are apple's neighbours, and predicts the next word based on the words that are near apple on the map of words, using probabilities to guess. This mathematical representation is fundamental to how the model predicts what you might write next. It's all based on the relationships between the words in the model's vast knowledge map. So why do we create text embeddings or vectors for documents? When it comes to entire documents instead of individual words, models like Ada apply a similar concept. Ada and other similar embedding models read vast amounts of text and create vectors for each document, summarizing their content in numerical form. Through training, Ada learns to position related documents close to each other in the vector space. When encountering a new document, Ada can find it and link it to similar documents based on their proximity in this space, aiding in understanding and categorizing complex topics without the need to constantly reread the content. Imagine every fruit on this graph represents a complete document, not just the word. Apple might be a document about fruit salads. Orange might be about citrus cultivation, and banana about tropical climates, let's say. We transform these documents into vectors, which are just lists of numbers that capture the essence of the documents in a way that computers can work with. The distance or angle between these vectors is like measuring how similar documents are. If the vectors of apple and orange are close, it means that these topics are related, like fruits. But if apple is close to banana in a different way, let's say the angle, it could be due to something that they have in common, such as being part of a fruit salad recipe. Transforming into vectors helps in tasks like retrieval augmented generation by finding the most relevant documents for the text that you have submitted. And now I can complete this part of the course with you, and here's the plan. 1. Begin by registering for an account on qdrant at https://cloud.qdrant.io/login. Go to the clusters section and create a cluster. Make sure that you stay within the 1 GB limit using Google Cloud GCP to take advantage of the free tier. You'll receive a message indicating no API keys created for this cluster or no API keys found. Click on API keys to start creating them. In the API keys section, you'll find the API key itself and a set of code examples for different programming languages. For this course, we will use the Python code example to connect. By following these steps, you'll leverage the capabilities of the vector database, which will enhance your efforts with RAG techniques. Let us first import the models and store the API keys for OpenAI and qdrant. Now, let's deal with the task of importing a massive book like Homer's Odyssey into the vector database while addressing some key challenges. Challenge number 1, the vectorization process. As we discussed earlier, we need to convert text documents into vectors. Now, while QDurant offers a direct method based on CPU to turn documents into vectors, I'll explain a way to convert documents using the Ada model from OpenAI because it's much faster than the CPU and is very cost effective. Challenge 2, dealing with text length limitations. As we embark on the journey of converting documents into vectors, it's essential to understand that everything returned by the vector database will be merged with your question and any other messages. Therefore, if you choose to host entire documents or books inside a vector database, you'll undoubtedly encounter limitations on the maximum number of tokens used by the API. This in turn can lead to increased costs even for simple queries. So how do we overcome this challenge? The solution lies in segmenting our documents into parts before starting the vectorization process. And after that, as I previously mentioned, we could even take it a step further by compressing the text. Let's continue. It's clear that presenting the entire book as a vector would be impractical, given the cost and limitations of the maximum number of tokens in GPT 3.5, which would be 4,000 or 16,000 tokens, and GPT-4, which would be 8,000 and 32,000. Therefore, let's segment our book into parts. We have at our disposal a variety of classes from the LangChain framework, and for this task we'll use recursive character text splitter dot from TickToken encoder. This tool is excellent for splitting texts into parts based on the token limits for a model like GPT 3.5 and presenting them as a list. Here we'll split the book according to the settings shown and store it in a list, and then store the contents of this list in a CSV file to give us a chance to display the contents and retain them. Now, let's shift our focus to the vector creation process. Here we'll create lists of vectors and put them in a CSV file as well. This is so we can examine the file and retain it to avoid having to connect with the API again. Now take a minute to check documents.csv as well as documents embeddings.csv, which has the vector lists. We are now ready to import these files into QDurant. It's worth mentioning now that we must repeat this process for every single document or book we wish to import, including the incoming questions, which we will address soon. At this stage, I will create a collection in QDurant called Books, and I will specify the settings for importing the documents. With your collection now in place, head over to the QDurant dashboard to view the newly created collection. Of course, don't forget to use your API key. Now we'll open the documents file with the vectors for reading in Python and then store the parts in the loop on QDurant under the books collection. And finally, we have successfully set up the vector database with data ready for searching. Return to your database dashboard and select the collection to explore its contents. Now, let's try the query functions in QDurant. Keep in mind that we still need to convert the query into a vector to ensure the process runs smoothly. As you can see, the output consists of 5 text snippets closest to the query you provided. These snippets are now ready to be presented to the language model to create an appropriate response. Shall we go ahead and wrap this up in a skill? Let's do it. As we previously done with the internet search skill, we will now write a function specifically designed for vector database search and then write its definition. And there we have it. We have successfully implemented a vector database, performed document and question vectorization, and created an automated question and answer QA chat that responds to prompts effectively.